Hi everyone. In this video we're going to be working on 2011 AP Free Response question number 5. Now this question was a very difficult one in this year. This question actually received the least amount of points on average, which was 1.63. And you have to kind of remember that this question is worth 9 points just like every other free response question. So students didn't perform as well as the other ones. So what we're going to do is we're going to take a look at A, B, and C, but first we're going to begin by reading the question. It says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. Okay, that means that in 2010, there was an initial amount of 1,400. So that's probably going to be at time equals 0. It says the increasing function, okay, so that means this function is going to be increasing throughout the entire time. It says, models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy a differential equation dW over dt. Now, when you see dW over dt or anything that resembles a derivative, understand everything that you can do with a derivative, which is slope, which is tangent line, increasing, decreasing, max, min, everything that you pretty much found in calculus for first derivative, understand that you might get asked. And then it says for the next 20 years. It says W is measured in tons, T is measured in years. Okay, so W is in tons, T is in years from the start of 2010. So that means that 2010 was your initial amount. Then it says, use a line tangent to the graph of W at t equals 0. Approximate the amount of solid waste that the landfill contains at the end of the first 3 months. Then it tells you time t equals 1/4. Now the reason why they told you time t equals 1/4 is because you have to remember t is in respect to years. So if they're asking for 3 months, well, that's not really a year. So you have to kind of create a proportion, 3 months out of 12 months in a year, which will simplify to 1/4. So let's go ahead and work on this problem. So the first thing you kind of want to understand in part A, when you see the word tangent line, which you are going to see a question on the free response and the multiple choice section, you first want to write, what is tangent line? That's y minus y1 equals to m parentheses x minus x1. Now you have to think about, okay, well, at what time? When do they want you to estimate? Well, they're telling you to use a line tangent to the graph at w at t equals 0. So that means your time is equal to 0. So that's my x values. So that means that what I'm going to do now is I'm going to do y minus y1, but what was the initial amount? What is the amount of tons at t equals 0? Well, that's the first I'm going to give you, 1,400. So this is going to be y minus 1,400 is equal to m parentheses x minus my starting point, which is 0. So the only thing that we're missing is m. Well, how do I find m? M is the slope. How do I find slope? In calculus, slope is a derivative. So I'm going to plug in time. I'm going to plug in my initial coordinates into my equation. dW over dt is equal to 1 over 25 w minus 300. Well, what is w? Well, w is your starting amount, which was 1,400. So you're going to take 1,400 and plug it in. So that's going to be 1 over 25 parentheses 1,400 minus 300. And then remember, this is on the non-calculator portion, so you're going to have to work this out. 1,400 minus 300 is 1,100 times 1 over 25. And this is going to equal to 44. So that means that your slope is 44. Well, what does that mean? That means that at time t equals 0, that was the initial slope. So this is going to be y minus 1,400 equals to 44 parentheses x minus 0. Now I should probably drop that 0. I don't really want to bring it around. So then I'm going to simplify this as y equals mx plus b. Y equals to 44x, and then bring the 1,400 plus 1,400. And if you're able to do that, then that right there is going to give you your points. Now the only thing that you need to understand is they were telling you at time t. So I don't really want to have an x. So what I'll do is I'll go ahead and change this to make this y equals to 44t plus 1,400. So it makes a little bit more sense. Okay, so that right there is my tangent line. Now the next part of the question is going to be, well, they want us to approximate at the first 3 months. And they told you at time t equals 1/4 because remember, t is in years. So 3 out of 12 will simplify to give you 1 out of 4. So I'm going to take that 1 over 4, I'm going to plug it in. So that means I'm going to get y is equal to 44 times 1 over 4 plus 1,400. And then simplify this. Remember, you don't have a calculator. Put this over 1. That's going to be 44 over 4, which is 11 plus 1,400, which is equal to 1411 tons. And that's our approximation. Okay? So this is pretty much a linear approximation, and we're using our tangent line to approximate for the first 3 months. And if you're able to do that, that right there is going to give you 2 points. 1 for the tangent line, and then 1 for being able to approximate at 1/4 time t equals 3. Okay? So anytime you hear the word tangent line, just think about tangent line is this equation. They're going to give you the initial coordinates. Well, how do I find m? I'm going to plug in the initial coordinates into my derivative, and then whatever I get, I'll plug it back into m, solve for y, and then if they ask you to approximate, just go ahead and approximate. So then we're going to move on to part B, where part B was a tougher question. Now part B tells you find d2w over dt squared in terms of w. Use d2w over, this is pretty much the second derivative, to determine whether your answer in part A is an underestimation or overestimate of the amount of solid waste that the landfill contains at time t equals 1/4. Okay, so there's a lot going on in this question. So the first thing I'm going to do is I'm going to find my second derivative, because this is always going to tell me second derivative in respect to w. Remember, in terms of w. Sorry, in terms of w, but respect to t. So I'm going to go ahead and I'm going to write my equation that they gave me, because I already have the first derivative, so all I have to do is just do one more derivative. Now, when we have this question, I don't really like the format. I don't like the fact that I have to have a constant in front of a parenthesis. So I'm going to actually distribute this out, which is going to be 1 over 25w minus, think about it, 1 times 325 times 1. That's going to be 12. Okay? And this is equal to dw over dt. Now, my next part of this question is, I'm going to go ahead and actually find this derivative. Well, derivative of this is 1 over 25. But this is not respect to t. Remember, this has to be in respect to t because it's dt on the bottom. So anything that doesn't have a t, I have to add dw over dt. And the reason why I added that was because of this reason. I found the derivative of w, but it has to be in respect to t. So anything that doesn't have a t, I have to add d of that letter over dt. And then the derivative of 12 is 0. Now, I don't have to add d something over dt because since my derivative is 0, 0 times anything is going to cancel out. So this is going to be d2w over dt squared equals to that. Now, your answer can't be left like that, and the only reason is you know what dw over dt is. They actually gave you this in the beginning. That's your first derivative. So you have to go ahead and plug that back in. So this is going to be 1 over 25 times 1 over 25, parentheses w minus 300, and then work it out, and this is going to give you 1 over 625, parentheses w minus 300, and this is your second derivative. Okay? So it was just a second derivative. If you're able to find that, you're going to get 1 point, but you had to remember that anytime you find a derivative of a letter and it's not in respect to t, you have to actually put d of that letter over dt, and this is just implicit differential, which you did in calculus in the beginning of the year. Okay? So this is my second derivative. Now comes the hard part. They want you to determine whether or not this is an underestimate or an overestimate from what you use in part A. Well, what did I find in part A? Well, I found in part A, at time t equals 1/4, I was supposed to get 1411 tons. So they want to know, is this going to be an overestimate or an underestimate? Well, that just means this is going to be on top of the graph or below the graph. Well, what's going to be on top of the graph? Your tangent line, because this, in order to find this, you use a tangent line. So you have to think about this. Okay. Well, when you find your second derivative, what does that help you find? Second derivative helps you find concavity. So if you were to take this and set this equal to 0 like you did in calculus, you're going to find your critical number. So I don't really have to worry about this because it's just a constant. I'm going to set that equal to 0. W minus 300 equals to 0. My critical number is 300. Okay, so then I would put numbers on the number line, 300, and then I'll test values left and right. Now, there's a reason why I don't have to test values, and that's because what was my starting point in tons? Remember, this is in respect to tons. My starting point was 1400, which is all the way over here. And if I plug 1400 into here, you're going to get 1400 minus 300 times that, still gets a positive. So that means that it's concave up. So your graph for the entire function is going to be concave up. It's going to be concave down anything less than 300 because let's say I were to plug in 0. 0 minus 300 is negative. Negative times a positive is negative, which means concave down. I don't even care about this because everything starts from 1400 because that's how much tons I have in the beginning. So this is concave up. Well, what does that mean? That means my original graph, I don't know how it looks like, but I know it's going to be concave up. Remember, concave up is like an upper parabola. Well, if my graph is concave up, and I have a tangent line, right? Let's pretend that this was at time equals 0. Time t equals 3 would be somewhere right here. My tangent line would look something like this. Okay? So let's say actually this was 0 and then this was 3. My tangent line will look something like this. But think about it. No matter what tangent line I always draw on this parabola, you're going to realize that this tangent line is always underneath the actual graph. So that means that 1411 is on this tangent line, which means that it would be an underestimate. And the reason why it's an underestimate is only because your tangent line is below your graph. So how is it going to be an overestimate? So for part B, your answer, by the way, would be this is your second derivative, and you got 1 point for that, and you got 1 point for being able to determine that there was an estimate. Why? Because your second derivative is concave up, which means the tangent line is below the graph. Therefore, it creates an underestimate. Well, how is it an overestimate? Just in case you got a question like this in next year or whenever. Well, let's say that this was the opposite, and my graph would be a concave up. Well, think about it. No matter where you draw a tangent line on this graph, you see no matter where you draw it, it's always going to be on top of your parabola or on top of your function. That right there would create an overestimate. Okay? So just kind of understand what that looks like and how you use a second derivative. So if they ever ask you to find a second derivative, they're probably going to ask you about concavity. So you have to set equal to 0, determine the values. Okay, so then comes to our last part of the question, and this is worth the most points. This is actually worth 5 points. What are they asking you to find? They're asking you to find a particular solution. So they want you to use a differential equation and find the antiderivative of it. So you have to remember a couple things. When you find an antiderivative of dw over dt, your goal is to get things alone. And what I mean by that is you want to get all the variables on one side that belong together and all the other variables on the other side. So when I have dw over dt is equal to 1 over 25 parentheses w minus 300, I'm going to cross multiply and get this dt over here. Now when I do that, I'm going to get dw is equal to 1 over 25 parentheses w minus 300, close them, dt. Now this doesn't really make sense in the beginning, and the reason is, if you look at it, this is a w and this is dt. They're not the same variable, so I need to get this w to the other side. So I'll divide by w minus 300 and I'll get this. 1 over w minus 300 dw is equal to 1 over 25 dt. Now this makes a little bit more sense. If you look at the left, they all have w's. If you look at the right, it's a number in dt, and that's fine. So then your next step from here is you actually have to go ahead and integrate this. So when you integrate this, you have to think about, okay, what is the integral of this? Well, you can't have 1 over anything. That's actually u substitution. So you're going to go to the side and go u is equal to w minus 300 du over dt is equal to derivative of w is just 1, and then solve for du over dw. Solve for dw, and this is what you're going to get. dw is equal to du. So then you're going to plug it back in, you're going to get the integral of 1 over u, because you made u equal to w minus 300 of du is equal to, and then I'll just keep the right side as it is. And then when I integrate this, now I can integrate this. Anytime you have the integral of 1 over u, you have to remember that's just ln. ln of u, absolute values, is equal to antiderivative of that. It's just a number, so add that letter, t. Now my last thing is, I don't really want u in the problem, and the reason is I know what u equals to, so I'm going to go ahead and plug in what u equals to, which is over here. It's going to be ln parentheses w minus 300, close it, equals to 125t plus c. Okay, so kind of going through the points that you would have earned if you got this far. You get 1 point for being able to break it up into the same side, so separating the variables. Then you get 1 point for being able to find the derivative of the left and the right, if you're able to do that correctly. Now, my next thing is I have to actually go ahead and find c. Well, where do they want you to find c? If you look at the question, it tells you your initial point, 0 and 1400, just like it did in part A and every single part. So I'm going to plug it in. So I'm going to get ln 1400 minus 300 equals to 1 over 25 times 0 plus c. And when I go ahead and solve that, I'm going to get c is equal to ln 1100. And if I'm able to get c is equal to 1100, that's another point. So now I'm going to go, okay, well, I'm not done yet because they want you to solve this. So I'm going to take this c, I'm going to plug it back into my original equation. So now that's going to give me ln, absolute value is w minus 300, is equal to 1 over 25t plus ln 1100. And then your last thing is, let's go ahead and solve for w because they want you to get w by itself. So how do I solve for w? I need to get e to both sides, and that's going to create this. This is going to cancel out, so I'm going to get absolute value w minus 300 is equal to e to the 1 over 25t plus ln 1100. Now, I don't really like how this looks because I don't want a plus sign, and remember, I'm able to break this up. This actually breaks up to this. Absolute value w minus 300 is equal to e to the 1 over 25t times e to the ln 1100, and then because I'm doing that, e and ln are going to cancel out. And the reason why I'm able to do this, by the way, is because whenever you're adding exponents, that means that you can break up the bases, so that's multiplication. How do you know that? Two things being multiplied means the exponents get added. That's exactly what I did there. And then my last thing is I'm going to bring 1100 down, is equal to, this is going to come down, but because it's being multiplied, I'm going to have 1100 e to the 1 over 25t. Now, you're almost done, but you have to get w by itself, and you're going to assume that your value is positive, and why? Because your values, your points, your coordinates was at 1400, so you always knew that this was going to be positive. So you're going to solve for w, add 300 to the other side, and you're going to get 1100 e to the 1 over 25t plus 300, and if you're able to do that correctly, then you would have earned yourself your last point. Now, solving for w only gets to 1 point. So if worse comes to worse and you're freaking out and you don't have enough time, maybe save this till the end. Because solving for w is only 1 point. And solving for c, up to c, is going to give you 4 points out of the 5. Okay? So once again, whenever you're separating variables, you have to make sure all the variables are on the left, on the right, and then integrate both sides. Make sure you do use substitution if you have to. And if you have to solve for w, just make sure, or solve for the variable, make sure that you have enough time because it's only worth 1 point. Alright, so if you guys need help in any other question with these, I have a couple more videos, so make sure you look at them and let me know what you thought. Thanks.